Okay, I think my network is a bit better now. I can start the stream. Let me just come here a bit. Nothing is showing yet. Wow, that's okay. What happened? What happened? I'm not sure what's going on. Content. Let's see. My life. It says upcoming. Okay, okay. I'm live now. Yeah. Ah, feels so good. I just want to confirm. Uh, okay, my stream is actually not good. Okay, yeah, I think it's better now. All right, so today I'm just going to go back and revise a few things, right? My plan is to actually okay. Let me set the time here. It's a bit late already, and I don't think I should have. Anyways, showing up is very important, so let's do 40 minutes. How about that? I'm going to cancel this. I'll set it to 45 minutes. Yeah, that's better. Okay. Um. So. My network is not good at all. Anyway, I'm just going to start the stream already and talk about a few things, revise some sliding window questions. Um, I have I have this. I selected a few questions, so I'm going to use explain those ones. I'm just going to come here. And say, where's my board? Escalidraw. Yeah, I'm not sure if I should go over uh the things I did yesterday, or I should just continue with a new question. Although these questions are very easy, so I chose them from. I want to solve everything in the sliding window, right? In this order, just for me to properly master the sliding window problem. So far, I've only solved 2 million questions. Um, so I think repetition is really key. In terms of mastering something, you need to repeat it a lot of time for it to stick. So I'm just going to start with this question. I'll solve this one first, right? I'll start with this one. So this question is a sliding window question, right? You can see it has hash table, string, and sliding window, and then counting. All right, we are going to solve this question here and now. So a good string. Okay, the title of this the title of this question is substring of size 3 with distinct characters, right? And so this question is an easy question, a sliding window question. So now a string is good if there are no repeated characters, right? Given a string s, return the number of good substrings, sorry, of length 3 in s. Okay. Now note that if there are multiple occurrences of the same substring, every occurrence should be counted. Okay, okay. A substring is a contiguous sequence of character in a string. I mean, we know this already, right? A contiguous sequence of characters in a string is what we call a substring. And we want to find how many good substring we have in a particular given input, right? In a particular string, right? Which is going to be our input. So how many good substring will we have in a string? And the substring has to be of length 3, right? And a substring also, the substring also has to have distinct characters. Now, when you recall, I mean, if you've ever solved any sliding window problem, you will notice that this is similar to the maximum sub array sum question, right? So I have I have the maximum sub array sum question here. Yeah, so this is a question where we are given a specific window, right? K is an integer that represents how many items we want to use in our array in order for us to perform an operation. So let me show you what I mean by that. So here is, so I'll come to this place. This is what I did yesterday. I'm just going to remove everything for now, and I will start with, so um let me just explain the question. The question is, this question says a good string, right? A string is good, sorry, a string is good if there are no repeated characters, right? Now, given a string s, return the number of good strings of length 3 in s, right? So that's all the question is asking. Given a string, we want to return the number of substring that are part of this, the input string, that is also a good string, right? A good string is basically a string that has distinct. I honestly, this network is really bad today. I'm just experiencing a lot of fluctuation. Um, I am really sorry if this is causing any inconveniences. This was supposed to be a smooth stream, right? But it isn't. Oh my god, I'm so angry. Come on, please. Please be stable for once. Oh! You can't do this. Please, 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 please. Please. My network is just really bad. Oh god. Anyways, so I'll just continue again from where I stopped. I was trying to explain this using an example. Oh, come on. What's going on? Really? What? I'm not sure if I can share this with you, but if you look at this, right, when in OBS, if you, when you have there's this bit rate count that shows, and you know, it just means you have a good internet or not, which is, it goes to green, which means good internet, and sometimes it's just at red, which is really bad, and that is Starlink for you, right? Terrible network. I can't believe this. This is unbelievable. Anyway, it's just better for me to continue talking instead of complaining about this, right? So I'll just go ahead and explain what this question is. But anyways, so back to our question for real now. The question is asking us to um return, right, the number of good substring, right? Return how many good substring or good string is part of our bigger string here. And for us to do that, we first of all need a substring, right? Now, okay, let me bring this back. Now, a substring is any set of characters that are part of the larger string, right? So here, if we have, you know, let's start with the first character. S here is a substring. XY is a substring as well. Even every other string in this string here is a substring of the entire string itself, right? So it's just like sets where you have items that are subset of a larger set, right? So, but this time around, the question is such that the question is asking for us to return how many the number of substrings, right, that are good strings. And a good string is basically a string with distinct characters, right? A substring that has unique characters or no repeated characters. Oh my god. Oh, please. Oh, I think I need to talk faster, otherwise this thing is just going to disconnect at some point. So now there are three things to. Oh, come on. Honestly, I'm having the worst experience today. This has this is not what I imagined will happen today, but I don't know. I think I just have to, keep going. Today is just a bad day. Anyways, we are given an input string and we want to get substrings, you know, of a certain size, right? In this case, we want three at a time, and we want to verify if if each set is actually a good substring, right? And a good substring is a string that has distinct characters or no repeated characters. So in this case, so for us to do this, right, we first of all need to take uh, a particular chunk of this string. So three characters at a time, right? Because we know we're told here, we're told. I'm just going to move this to this place. We're told the giving a string as return the number of good substring of length 3, right? So we need to check 3 characters at a time, right? Our substring has to be of length 3. And if you think about it this way, right, that means if you think about it in terms of sliding window, it means our window has a length of 3, right? So our window has a start here and an end here, right? And every time we iterate through the string, we want to get 3 characters at a time. So in our first iteration, we'll start from this point all the way to this point here. And second iteration, we'll go from this point all the way to this point here. And then we'll do that for every characters until we reach the end of our string, or the end of our window reaches the end of the string, right? Which is this place. So let me, that was a bad representation. So let me improve that a bit. So I'll say we start from this point here all the way to here. And then we go from here. Our window has to maintain this size, right? We'll start from the second character all the way to the third, all the way to where our window uh, asks us to stop at. Let me do it this way. I'll start from here all the way to here, and then from here all the way to here, right? Right, this is 3, and then we want another 3 again. So we'll start from here all the way to this part here, and then another 3 again will be from here all the way here. Now you can see, with this representation, we have 4 squares, right? And this is basically, the size of our window, and it means we have 4 possible substrings that we can create out of this main string here, that is going to be of size 3, right? So 4 substrings of length 3 will be, created out of this string S here. Now we also need to verify as well if these substrings are good strings, which means if if these substrings have distinct characters. So in the first case, I'll call this 1, right? This is our first window, right? We selected items from the first character all the way to the third one, right? Because we want to maintain that size, that window. The size of our window is going to be 3 because we want substrings of length 3, right? So from this point all the way to this point, we'll have x, y, z. Now, does x, y, z, respect or validate the condition? Is x, y, z valid for a good string? We know a good string has to have distinct characters, right? So when you look at this string here, right, this indeed is a good string because x is just appearing once in this substring here, and y is also 1. We have only 1 z. So yes, at this point we have one good substring as part of this string, and then we go again, we check for the second case, right? The second case is going to be here. The second substring, right, is going to be here all the way to this point here, and in this window we have y, z, z. Again, is this valid to be a good substring or a good string? No, this is not valid because we have z appearing twice here, right? So this will not count. So far we've only had one good string as part of our string s here, our input string s. So we go again, we start counting. We start from this point here, right, all the way to this part here. So this is going to be z z a, right? Is z z a valid good string, or is z z a good string? Z z a is of course not a good string, so we don't count z z a again. So we go again and we continue from this point all the way to this part here. So we'll have z a z. Again, this is not a valid this is not a good string, right? So this is not a good string, and so far we've only had one good string in this entire string here, right? Or one good substring in this entire string here. So the result of our function, or what we return at the end of our function, is 1, right? We want to return how many good strings we have. So that's how this question is going to work, and I will just implement that right now. So let's go ahead, and now one thing you'll notice is every time we are shifting the window towards the right. So let's say if this point here, if this point here was our start and this was the end of our window, right, it means we have to increase them by 1 each time, right? We need to shift them towards this the right, and make sure that we always select 3 characters at a time, right? We're always selecting 3 characters at a time. And also we need to validate the characters within this window, right? So the first window is going to be from this point here all the way to this point. Second window is going to start from here, right? Which means we are increasing our start, right? The start of our window and the end of our window as well. So I'll call this end here, right? This is the end of our window and the start of our window. And the size of the string that we have in that window or within that window is going to be equal to 3, right? So let's go ahead and implement this. I'll just open my code editor now. Da-da-da. So we have this. I'll call this so I'll put this in the sliding window problem, right? Sliding window. Where's sliding window? Okay, so sliding window. Yeah, so what's the name of this question? This question is I think sub size. I mean, good count good substrings. So I'll just call it like that. I'll say count. Oh, caps, not caps. So we don't want caps. I'll say count, not down, count good dash substrings, right? Okay, so this question is relatively simple. So I'm just going to come here and copy the starter, right, and paste it here. So we are given an input string, and first of all we want to return the count of unique a good substrings that we have as part of our main input string. So here are the variables we'll need. First of all, we'll need the I'll say total count, or I'll call this count, right? This is what we return at the end of the day. Count is going to be equal to 0, and I'll create a different variable. I'll call this start, which is going to be the start of our window, set to 0, and end is going to be equal to 2, because we need 3 characters at a time, or a substring of length 3. So end is going to be equal to 2, and yeah. So now what do we do next? Well, we need to iterate through the string and select some characters at a time, right? So 3 characters at a time, sorry. So I'm just going to do this. So I'll say while the end, right, the end is less than the length of the string, right, less than the length of the string, we want to select 3 characters. So how do we do this? I'll say, okay, so I mean, let's print something. Let me show you something. If I printed s at start, so I want to use string slicing, start and end, so it will not include end, so I'll just put end plus 1 like this. So each time we know we are going to increment end and start, so end plus equal 1, start plus equal 1. Let's do it that way. So I'm just going to call instantiate. I'll call this solution and set this to solution like this, and we can print solution dot count good strings. And this is not going to return the good strings per se, but we want to see, the valid substrings that we can create of size 3, right? So I'll just pass this here, and let me run this and see what's going to happen. Okay, so you can see we have SYZ, YZZ, YZA, and ZAZ. So with this, we can begin to validate the string, right? So I'll write a helper function that will take in these strings here, right? That will take in these strings and then run some validation on them, right? So I'll create a okay, let me just show you what I'll do. Let me create my helper function. Define valid sub. I'll just call it valid string, right? Or not valid. Good sub string. Good sub string. Good sub. Oh, you know what? Let's call it good string. Good string like this. I'll just call it a good string, and this will take the string that we select here, right? This string here. Well, I don't want to do this all the time, so I'll pass in two pointers, right? Or two pointers. So I'll call this I and J, right? So this was basically represent the start and the end, right? Instead of calling them by J, I'll just call it start, and I'll call this start like this just to differentiate it from the other one, and call this end like this so that it's different. And I'll just say, okay, so I'll call this start one, and no, I can call this start and end like this. Nothing will happen, right? Yeah, so this will be scoped to this function here. Okay, so I'll create a dictionary. Now, why do I need a dictionary? Or I'll create a set, right? This set is going to help me keep count of every unique items, right, in the string. So I'll say unique characters, right? Unique characters is going to be a set, and this set will hold each characters for me, and I'll call this the substring we want to have a look at, right? Substring, or I'll just call this sub. Yeah, sub is going to be equal to S. So I'll do the direct thing here. So S at start, and it's just the same as this, but instead of me passing the actual string into my function here, I just want to use indexes and select the string inside here. So it means I'm not creating the string over and over again, right? So I want to start and end here, right? End plus 1. So then we'll now iterate through the substring and get the valid ones. So let's say so I'll use a for loop here. So for I in range do I need I in range? Nah, I don't need that. I can say for character in sub, right? For characters in sub, I want to do this. I want to say if the character is not in if the character is not in unique characters, then I want to add it to the unique characters. So unique characters dot add this character, right? So that's it. And otherwise, right, it means in the case where we've seen this in the case where this condition um, becomes invalid, right? Which means the character is already in the set that we have here. Then we just want to stop, iterating, right? So let's return. I'll let this function return 0 or 1, right? And we'll just use the return value to increment our count here, right? So I'll return 0, but in the case where this loop is done running and we did have we didn't get to this point here, I'll return 1. So return 1 like this. So yeah, then each time we increment this, so instead of printing here, I'll just remove the print, right? And I'll say count plus equal the return value of our function here. So what's the function? Good string, and we'll pass it the end. No, sorry, start and end. Start and end, right? And yeah, so with this, we know here, what's this? The output is supposed to be 1. So let's run this function and see what we get. So this is none. Why is it none? Because our function is not returning anything. So let's return the count. Return count. Right, so we can return count. Let's run this. Now I can see the answer is 1. So we are good to go. I'll just remove this comment here and run this in LEETCODE. So here, and let's see what goes on. So fingers crossed. Yep, we passed the 2 test cases here. And is there any edge case? S consists of, so the length of the string is going to be superior or equal to 1. Well, what if it's equal to 1? Let's see a hint. Try using a set to find out the number of this thing. Yes, I've done that already. Let me submit this. Oh, it worked. The reason why the runtime is not really, I don't think anybody should be bothered about this so much, but the reason why the runtime here is not really high is because we are running a loop within a loop, right? So this function call here has a different loop in it. So basically this automatically O of n squared, quadratic time complexity. So it doesn't mean this solution is not efficient, but it just means that there's room for improvement, right? So I'm not going to bother much. I'm not going to bother myself about that. But I'm just going to look at this later on and see how we can improve this. Otherwise, this is good. This is good for now, because we need to keep track of every three characters long substring in our main string. All right, so that's it for this one. I'm just going to go to the next question. So next question will be what? So this is another easy question. I hope it is actually easy. All right, so let's see what we have here. Now, I said I'll be putting some stuff in Excel. So fingers crossed. I need to keep updating this shit. But at the end, I'll do the updates and keep everything clean. All right. I think that's it for now. um, let me solve the next question. The next question is diffuse the bomb. Okay, you have a bomb to diffuse and your time is running out. Your informer will provide you with a circular array code of length n and a key k. Hmm. To decrypt the code, you must replace every number, right? Decrypt the code, you must replace every number. All numbers are replaced simultaneously. If k is superior to 0, right, replace the ith number with the sum of the next k numbers. Replace the ith number with the sum of the next k numbers. Okay. If k is less than that 0, replace the ith number with the sum of the previous k numbers. The previous k numbers. If k is equal to 0, replace the ith number with 0, right? As code is circular, the next element of code n minus 1 is code 0, and the previous element of code 0 is code n minus 1. Okay. Given a circular array code and an integer key, return the decrypted code to defuse the bomb. This is an interesting one. Okay, so what's this question about? What's this question about? Let me refresh. Google keeps YouTube keeps telling me my stream is bad, right? This is my stream here, but you know what? We're good. Which is why I look towards my left from time to time. Anyway, we have some bomb to diffuse, right? So let's take a look at some examples. We are given a code, right? The code is going to be the circular array, and the first condition is that if k is superior to 0, then replace the ith number with the sum of the next k numbers. So we'll replace the ith. So here we'll replace it with the sum of the next k numbers. So replace this 3, right? So this is going to be 3. So 7 plus 3. Oh, okay. Oh. Wow. Okay, so this is going to be 12. Oh, there's an explanation here. Each number is replaced with the sum of the next 3 numbers. Yes, exactly. So, a circular array means every number can be the next number. Any number can be the next number. So when we are at this point, we can add 7, the sum of these, right? And when we are at this point, what do? And we replace the value with whatever was here, with this I here. So we have 5. We replace 5 with the sum of the next 3 numbers. 7. When you're at 7, we want to add every number here and 5 too. Okay. Right. So to get the previous number, which is this explanation we have here. Okay. Not this, but yeah, here. So let's see the second case. So if we have k is equal to 0, we replace everything with 0. Okay. Now we can see there's K is going to be the size of our window, how many items we are selecting at a time, right? I mean, this is a sliding window question, so I'm just thinking ahead of my solution, what I want to implement. So we have an input code 24993 and k is equal to -2. So what does -2 mean? We still have 12 here. What does that mean? Sorry. So in the first place, we take 3 plus 9. Okay. So, oh, wow. I mean, -2, right? -2 for negative numbers. What does it mean? For if k is less than 0, replace the ith number with the sum of the previous k numbers. Ith number with the sum of the previous k numbers. So I mean, if I'm here, I want to replace it with the previous k numbers. So what is the previous? Oh, the array is circular, right? So previous k numbers will basically mean that, these two are probably in front of this. Okay, so this is 9 and 3, which is 12. And then when we replace this, right, so we do 9 and 3, we set that, and what else? um this is an interesting question. So replace this by 9 and 3. That will be the first one. The second one will be 2 and 3, right? 9 and 3, 2 and 3. And the third one will be 9 and 4. The fourth one will be 9 and 4 and 2 and 9 and 4. Interesting. So what do we do in this case? Let's see some hints. As the array is circular, use modulo to find the current index. Thank you. I was thinking about that anyway. So the constraints are low enough for a brute force solution. Okay. Topics, array, and sliding window. Oh, sorry. Let's visualize this first and see how we can solve this question. So I'll take my first input, right? We'll be given a code and a code and a so this is our code, and by k is what does k represent? Let me just close this sliding window problems. So I'll solve this now. So what does k represent? K is the key, right? How many characters from the code we want to combine to create each by the array being circular, right? If we do this, if we have a circle like this and write root 5, 7, 1 and 4, right? So I should have used a different color. Let me say 5, 7, 1 and then 4. Okay, this is our circular array. So we want to decrypt something, which means we have to create a new array. So the first item is going to be equal to the sum of the items in front of it. Yo, keep it up. I'm working with you. I hope that by the 100. Oh, I mean, yeah, this is studying, right? Yeah, somebody just commented in the chat. Yeah, nice one, nice one. Just keep at it. We are all studying, and yeah, it's good to know, people are also doing the same thing. Right, nice. So let's carry on with this question. So in the case where we have, so I'm just going to break this down and see how far I'll go with my own solution. So here we have uh oh, nice to meet you. Um I'm in Nigeria myself. Yeah, it's good to have you in the chat. I'll just let me pin your chat in here. So keep up the good work. Um, I hope one day we'll be able to uh solve some questions together. All right, that's it. Now I am off to the question. Okay, so what does this? Yeah, let me come back to this. So I mean, circular array doesn't really mean something complicated. I'm just trying to visualize this. So we want to sum the next three items at each point, right? So which means in the first iteration, right, we'll obviously run a loop, right? So we want to select three items at a time, but we want to, so at this we are at this point, right? We want to select every item in front of it. Now if you look at this circle that I created here, right, this will be considered the items in front of 5, right? So we'll sum them up, right? This will give us 12. And you know for 7, right, at this position, we'll take every item in front of it. So every item in front of it is from here to here, and then back to this one here, right? So if you look at the circle, you will see from 7 we have 1, we have 4, and we have 5, right? So those are the items in front of it, and that will be the same thing for um every other number in the code array. So at this, for the second number 7, we'll add 1 and 4 and then 5, right? So this will give us 10, and we are here now. So every number before it, right? So this will go from here all the way to here, right? For 1, we are going to sum 4, 5 and 7. So 4, 5 and 7 will give us how much? So let me remove this. Okay, so this is 12, 10, right? And this is give us another 12 again, right? 4, 4, 5 and then 7. Oh, sorry, that's not 12. Where's the eraser? This is 10. I mean 4 plus 7 is 11, plus 5 is 16, yeah. And then we have 4 items, so for 4 we'll take everything here, right? So but how do we get each item in front of the current item? How do we do that? I don't want to waste too much time on this question. I can just go ahead and look up the solution, but I'm sure they didn't provide any editorial, right? I am very sure they did not. they did not provide editorial. Let's see. Yes, no editorial for this question. So, I mean, one way to do this is to just have a look at the. I mean, I haven't tried this to see the submission. I know what needs to be done, but in terms of code, right? So, we'll sum up these three items first, which will give us 12. We'll sum up the next items in front of this, which is 1, 4, and then 5, right? So each time we can go back, right? When we reach the end of this array here, we can go back to the next items. But how do we do that? I mean, for 4, we'll have 1. This will be 8. 8 plus 5, 13. 13, right? This will be our final result, and we'll return this. I'll just implement a brute force solution, right? So I know let me use my playground again. So let's say playground. Where's playground? Okay, so we have playground here. Right, I'll call this define return. Define. What's the question again? Decrypt, right? So it's called decrypt. Okay, so now I need to at least 3 conditions, because k can be superior to 0, k can be 0, and k can also be hold on. If let's say I'm just going to start it here so that I test things out quickly. So I'll say if first of all, I'll call this decrypted. Decrypted is going to be an array. Decrypted is going to be an array of what? An array of 4 items, right? Because an array of 4 items. So I'll use this as a placeholder. I'll say 0 return 0. Okay, so 0 times the length of list of the code minus 1, right? Length of code minus 1. No, length of code is going to be how many? It's going to be 4, right? So okay, we want 4 items. Let me just do it here. I'll copy this, right? Let me just show you what I'm trying to do. I know for sure that I'll need to have a certain size of decrypted code, right? So if I do this so I don't need any for this in range length of the code, right? This will return let me just print this here. I'll show you what this does in a minute. Just hold on. I'll say code here. I'll call this code is equal to 1. I think our code is what's our code here? Our code is 5 for okay. I'm just going to do this, right? Oh god. I'll say this is the code. Carbon. Yeah, this is my code, and I'll print the decrypted. Print decrypted like this. You still will have 0, 4 zeros in a new array, right? So now you can see, and every time I'll replace this with the newly calculated value. So now let's go back to LEETCODE. So for this, I've already done this here. Let me just copy it. Decrypted. So I know. I know if let's handle it test edge cases by edge case. So if k is equal to 0, we want to return 0 0 0, right? So if k is equal to 0, then let's just return the decrypted, right? Return decrypted the way it is decrypted. So I mean, if I run this, the second edge case will pass. I know that for sure. So what's this? Oh, sorry, I didn't add this here. You can see the second case was passed, right? For k is equal to 0, which is okay. Now we want to check again. Now for k is superior to 0, right? For k is superior to 0, what do we do in this case? We need to take every item in front. So now if k is superior to 0, now how do we know the position of each item? Well, we know in the first we have to iterate through this, right? And we need to start from, we will not include this number here, but at the same time we can't ignore it, right? Because we also need it for the rest of the numbers. I don't know. So what do we do here? So in the case where if k is superior to 0, replace the ith number with the sum of the next numbers. So the sum of the next numbers, if we use the way we sum things up in sliding window, just by first of all calculating the first sum, right? I'll say the sum of the I'll say first next sum of the first next numbers. Oh, first next num is going to be equal to sum. Want to sum from 0. Hold on. Want to sum code, right? Code code at 0 0 0. I want to start from 0 all the way. I want to try and slice the string, right, all the way to k, and k, in this case k is going to be equal to 4, right? So no, not 4, 3. So if I put k here, it will stop at 2, so I'll put k plus 1, and this will return my first sum for me. I'll just print this and see what is inside. Print first. I'll call this first next. Yeah, first next num. It's okay. Let me copy this and paste it here, and I'll just run it from here. So this is going to be like this. Oh, that would be bad. Alright, so I can print this. I'll just remove this from here, and I'll just say solution. What's going on? Solution is equal to this solution here. Instantiate the solution class, print print solution dot decrypt. We use this here, and k equal to 3. Now the idea is to k is equal to 3, right? So this is it. The first sum should give us 12, right? 12. This is 17. Oh, we are not supposed to start from 0. We are supposed to start from here, right? From 1. We have 12 already, but we want to do this for every item, right? How do we know which item is in front? That's another tricky one. I mean, for the first one we can do this. The second one will be relatively, I mean, at this point I think we might, yeah, this will just start from here and go, but we want to include the last one as well. So what do we say? Do we call this like the end and say, so let's say end is equal to k plus 1, right? Now end is basically an index, right? K plus 1. And if I print this, right, print k plus 1, k plus 1 is going to be equal to 4. So which is the fourth, this point here, this and that, and we are starting from 2. We are starting from 2, which is here. So this will be here to here, right? We want to include this too. Or do we use, oh, I see. So when you look at this, right, 2 would have started from here, and we want 3 items. So if we don't have 3 items, it means we have to take more from the start, right? So how do we do that? We have to take more from the start, right? So which means if this here, so some here, right? Some here 5. This will give us 5, but we want to include 5 here. I mean, if we did this plus, code at 0, then we'll be able to get the 10 that we want, right? And we'll insert it at this position here. So which means every time we reach almost towards the end of the array, this is going to be 2. So the entire length of our string is what? Is 4. So we want 3 items at a time, right? 3 characters in the array at a time. This is quite tricky. Maybe I'm not thinking about it very well. So that's enough time spent. From here all the way here, and then from here back to the front. If we don't have 3 items, right? If this is not 3, then it means we already reached the end of the array, and we can now add an item to get exactly 3, right? Let's say we are forming an array each time, and our iteration has to go from this point to, so let me start implementing this. Let me do it this way. So I'll say for I in range, the length of code, right? The length of code, right? The length of code. If we print, let me just print I for now. Let's be sure that we'll get 0 all the way to 3. Yep, 0, 1, 2, 3. Okay, good. Now, we know we will have a particular window. I'll call this a window, right? So I'll say, you know, in the first iteration, we should, so we can calculate this from hand. First, next num. I'll do this, right? I'll start here. I'll start here like this. But these two has to, I'll say, I'll put this here. I'll call this window, right? Our window has to have 3 items at a time. So window, I mean, we don't need window here, so that's not a big deal. So here we need this. We need this in the first iteration. I'll say for some, let me remove this here. We are adding every item here. First num, right? And you know what? I think I should call this window. Window is equal to this, right? And I'll just say sum the window up. Sum every item in that window. Sum it. So this will return a sum, and I'll say so if the length of the window, which is 3 for now, I mean, oh, that's not gonna work, is it? Yeah, I mean, it will work. it should work. What's the length of this window first of all? Let me just. It should be 3, right? Sorry. Let me just pass this. 4. How? I mean, 1 3 items, right? 1 3 items. Why is this? You know what? Oh, sorry. I know why it's not. Print this. And what else was I printing? I was printing k plus 1. No, we don't want that. Let's do this. So it is 3. So you get to a point where this will not be 3, so we need to make it 3. But how do we even do that? Well, we can do that by just adding 1 more to it, right? From the start. Nah. You know what? Let me have a look at a solution. That's just really a waste of time. Oh, somebody said most easy. Ooh, easy Python solution. Let's see. So, yes. Okay, same thing here, right? So for j in range, okay, sum is equal to 0 for index j. So this is going to be the index, and then we start from I. What's going on here? What? Hold on. There's not even any explanation. I'm not going to waste my time looking at that. That is not good for my mental health. So no prefix, no reverse. Cyclic, iterate. Let's see. Okay, better. So we take temp code, we do code times 2. What does this do? Code times 2, we multiply the array by 2. Is that what it's saying? If k is equal to 0, return for I in code. Yeah. Oh, okay. We could do that as well. We don't even need. I mean, nice. So temp code this that. So we have code here again. range length of the temporary one. So we sum code if k is superior to 0, we want to use I plus 1, I plus k plus 1. Oh, I plus k plus 1. And then we have what here? Sum the code here within this range. What does costa? I mean, when you multiply an array, what does that do? I just print cause it's code and then print code times 2. What does this do? What? Oh, wow, this is brilliant. So they multiply the array is being multiplied to create every. So come on, this is good. So what's basically happening here is, for the first item, right? For the first item, we'll just take this. We'll start summing up from here all the way here, right? Second item will be 7, so we want to start from here all the way here. Third item, oh my god, that is, oh, wow. This is brilliant. I mean, it's increasing, memory, right? But like, it just it just makes so much sense. Somebody did a shorter version. A shorter version. Wow, and I was sweating. Christ. So I mean, for this minus that, we start from, so code at I will be the first item. Code at I minus code at I, right, minus code at I plus k. K will be 3, so 0 and 3, 0 0. Code at I minus 3, so k is 3, which will be here 1 2 3. So we'll sum all of this, right, and then we'll shift again and again and again and again. Y in range 2 minus 1. Yeah, I mean, for the calculation, that makes sense. So I mean, you could do this, right? We could just multiply the code by 2 so that we can have, every other item in front. And the summing, for the summing, we'll just do this. We'll take the first item. I mean, what I was trying to do is, even the decrypted code, right, I still want to use it as my final version. So here's what I'm going to do. So if k is superior to 0, right, it means we're starting from 1 plus. So I'll do this. I'll say code. I hope I really understood what that question was about. So I've already, let me multiply this. I'll say code. Yeah, I'm not returning decrypted. So code 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 times 2, and then I'll use this for my iteration, right? So for I is equal to, I'll just do this, I'll just use this for my iteration, like this is done here. So for I is less than k, I mean, why is it doing it this way? Code len code, okay, accumulate. Oh, sorry, this is the original. Oh, I didn't scroll to the, yeah, so len of them. So here we take code I plus 1 for the first sum, okay, right. And what do we do here? We say, I mean, this is the part where I'm a bit, so for I plus k, so in the first iteration we might have, you know, let's say this is going to start from 1 all the way to k plus 1, right? Because I is going to be 0 at this point. K plus 1 is going to be the fourth item. So from 1 all the way to the fourth item, right? 1 from 1 all the way to the fourth item. Okay, in the second iteration, we will start from here, right? Because I from here, right? We're starting from where? We're starting from I, right? I plus 1. Okay, so is I going to be 0 at first? Yes, it's going to be 0. Okay, I want to really understand this. So it's going to be 0, 0. So here, second iteration, I plus 1 is going to be 2. So we are starting from here all the way to this point here. K is going to be equal to what? K is going to be equal to 3 plus 1, which is 4 and 5. So the fifth item here is 5 here. Oh, and so on. So we'll do that for values that are superior to k. But for values that are less, I mean for the cases where k is less than 0, right? We want to start from the end of the array. So we'll start I plus len of 10 plus k. So which is the initial array. So I mean, we are still using this, right? So all the way to then of the temporary value. I plus len plus temp. I plus len plus temp temporary. Oh my god, it's almost 12 o'clock. I can't stream until 12. So for values that are, less, for values where k is less than 0, right, which is this case, we want to start from the end of our, so we want to start from here all the way to here, right, all the way to here, and then we'll shift each time. We'll shift in time until we get to this point here. I'm just going to push this since it's almost 12 o'clock. Git add, I'll continue tomorrow. Git commit dash what's the question I solved? It was count good substring. I'll put this as it's a sliding window, right? Sliding dash window, and count count good. Okay, count good substring. A is main. So the solution for this question here, count good substring, is on LeetCode. I mean on GitHub. The link is in the description. You can have a look at it. And tomorrow I'll find a way to understand that the second question properly and explain. All right, that's it for tonight, and we shall continue tomorrow for what day 35. So tomorrow is going to be day 36. There's more